Modern navies are highly dependent on air power. Land-based maritime patrol aircraft like the Lockheed P-3 Orion constantly overfly the oceans on long-range anti-submarine and reconnaissance missions. The E-2 Hawkeye provides the fleet with early warning of impending hostile attack. The principal warship is the aircraft carrier, a position it has held since the dark days of the Second World War. The carrier's jets both defend the ships of the fleet and provide the main means of attacking hostile ships and targets on land. Helicopters, too, play a variety of roles in naval operations. These range from anti-submarine warfare through search and rescue and liaison between ships to resupply. The helicopter, too, has had a radical influence on amphibious warfare, with its ability to rapidly deploy troops and equipment to the landing beach. Modern navies cannot function effectively without air power. Yet during the first decade of this century, the situation was very different. In those days, the mighty dreadnought, all-big-gun battleship ruled the seas. The battleship's guns became ever larger, until by 1914 they'd reached a caliber of 16 inches. These guns could fire a shell weighing almost a ton to a distance of 10 miles. The main eyes of the fleet were the cruisers, which scouted ahead of the main force. But they soon became outpaced by the dreadnoughts. Consequently, the battlecruiser, as fast and almost as powerful as the battleship, but less heavily armored, was introduced. This meant that the light cruisers were often relegated to operating independently of the main fleet, sometimes in distant waters. The final element of the surface fleet was the destroyer. These operated like terriers, yapping at the heels of the enemy fleet and looking for the opportunity to loose off their deadly torpedoes. Even though powered flight had begun in 1903, the concept of air power tailor-made to support navies was not much more than a dream. Some claim that American Samuel Pierpont Langley was the father of naval aviation. In the 1890s, he successfully launched model aircraft from the roof of his houseboat on the Potomac River, but failed to achieve powered flight. This allowed the Wright brothers to attain aviation's greatest milestone. Even so, the US Navy honored him by naming its first proper aircraft carrier, completed in 1922, after him. By 1910, however, the float plane had made its appearance, and navies began to show an interest in it. But these early seaplanes could only operate in the calmest of seas because of their flimsiness and lack of power. Furthermore, their range limited them to coastal waters, while what navies really required was flying machines which could operate with the fleet and provided with eyes which could see over the horizon. The German answer to this was the Zeppelin airship. This had many times the range of the existing heavier-than-air flying machines and hence could be land-based. By 1914, the German Navy had Zeppelins in service and operating over the North Sea. The other option was ships carrying and operating aircraft, which could accompany the fleet. But it was to be some time before this type of vessel appeared in a form which we would recognize today. The first steps towards developing aircraft carriers came in November 1910. Eugene Ely was the test pilot for Glenn Curtis's aircraft company. On the 14th of November, he made the first ever takeoff from a ship, the cruiser USS Birmingham, which was anchored in Hampton Roads, Virginia. 2 months later, on the 19th of January 1911, Ely went one further. He landed his Curtiss Model D on a specially constructed platform on the same warship. An arrestor hook attached to his aircraft caught ropes stretched across the platform and brought it to a halt. Ely himself commented,
"It was easy enough. I think the trick could be successfully turned 9 times out of 10.
Sadly, he was killed later that year while giving a flying display. In Britain, Ely's achievements were echoed by the Royal Navy officer Charles Rumney Sampson. Sampson's short S-26 was first maneuvered onto a whaler. It was then winched on board the pre-dreadnought battleship HMS Africa, where a platform had been constructed on the forward deck. Sampson started his engine and then made a successful takeoff. But while Ely's and Sampson's achievements were spectacular, navies were concerned that constructing takeoff platforms put a warship's guns out of action. While further experiments were carried out, the concept of the warship-cum-aircraft carrier was not immediately adopted. Thus, when war engulfed Europe in August 1914, fledgling naval aviation had just 3 elements: land planes, seaplanes operating in coastal waters, and Zeppelin airships. None gave the fleet on the high seas the intimate reconnaissance capability that it really needed. But this would soon change. In 1914, the British aviation arm was divided into 2 parts: the Royal Flying Corps, which was part of the Army, and the Royal Naval Air Service. It had been agreed that the RNAS would be responsible for the air defense of Great Britain, while the RFC supported the British Expeditionary Force in France. The main British fear was that the Zeppelins would launch a bombing campaign against England and also inhibit the operations of the British fleet. Winston Churchill, who as First Lord of the Admiralty was the political head of the Navy, therefore ordered attacks on them. RNAS aircraft operating from bases in Belgium were to bomb the Zeppelin sheds at Cologne and Dusseldorf. These, however, caused only slight damage. But by early September 1914, the German armies had overrun much of Belgium, putting the Zeppelin sheds out of range. Yet Churchill was still keen to maintain his attacks on them. Some could only be reached from the sea. Consequently, 3 passenger ships were hastily converted into seaplane carriers. These vessels, Engadine, Empress and Riviera, were the original ancestors of today's aircraft carriers. They had large hangars, which housed 3 or 4 short seaplanes. But getting the aircraft into action and recovering them was a time-consuming and laborious business. The seaplanes themselves were fitted with folding wings, so that they could be stored in the hangar. The first action that the seaplane carriers saw took place on Christmas Day in 1914. The target was the Zeppelin sheds at Cuxhaven, on Germany's North Sea coast. 7 seaplanes took part in the attack, but fog prevented them from locating the Zeppelin sheds. Yet their presence caused such a stir among the German warships anchored there that they raised steam and made for the open sea, 2 cruisers colliding with each other in the process. It was a portent of the future, when naval aviation would become a prime threat to surface vessels. In the meantime, the Royal Navy had built its first custom-made aircraft carrier, HMS Ark Royal. She was conceived as a result of trials in 1913 of a light cruiser converted to take 2 seaplanes. Ark Royal had cranes to recover her seaplanes, but also carried land planes, which would land on shore. Both used trolleys to take off from the deck. In February 1915, Ark Royal was sent to the Eastern Mediterranean to take part in the Anglo-French operation to force the Dardanelles, which separate the Mediterranean from the Black Sea. The first task of naval aviation, both British and French in the Dardanelles, was control of warships' gunfire against the Turkish forts which dominated the straits. This was made possible through the development of air-to-ground radio. However, the bulkiness of the early sets and the mechanical unreliability of the aircraft restricted their usefulness in this role. Matters were improved with the arrival of a new type of aviation vessel in early April 1915. Manica was a tramp steamer, which had been hastily converted to carry an observation balloon. This proved to be a much more stable platform for directing naval gunfire than aircraft, with the observers linked by telephone to the mothership. But naval aviation in the Eastern Mediterranean developed another role: attacks against ships. Initially, small bombs were used, but proved to be of little effect. The Russians in the Black Sea waged a similar campaign, using types like the French-designed Farman Type M floatplane. Sometimes, to give added flexibility, they used their warships to tow seaplanes closer to their targets. This was a technique that could only be used when the sea was calm. German seaplanes operating from the Belgian coast also made attacks on shipping in the North Sea and English Channel, but without proper bomb sights, the chances of hitting the target were slim. However, during the first half of 1915, another aerial anti-ship weapon was developed, the torpedo. The first successful aerial attack on a ship using this weapon took place in the Dardanelles in August 1915, when a short 184 seaplane sank a 5,000-ton Turkish steamer. But the added weight of the torpedo, even when the aircraft's fuel load was reduced, often made it difficult to get airborne. Indeed, it was for this reason that the first success was achieved with the aircraft still on the water. The German answer was to use larger two-seater seaplanes like the Gotha WD-14. Another type was the Dornier RS-3, but they were more difficult to fly than the smaller seaplanes. In both cases, to aim the torpedo with any accuracy was also a challenge. Even so, the threat was sufficient for warships within range of these aircraft to take precautions, such as deploying anti-torpedo nets. The main focus of attention for the German and British navies was the North Sea. Here it was believed the decisive battle would be fought. But not until the end of May 1916 did a real opportunity arise. Admiral Reinhard von Scheer, the German High Seas Fleet Commander-in-Chief, had hatched a plan to destroy the British Grand Fleet in detail. He intended to draw out the British battle cruisers from their base at Rosyth by mounting a bombardment of towns on the English east coast. U-boats and Zeppelins were to be deployed. These would monitor the movements of the battle cruisers, which would then be surprised and destroyed. Once this had been achieved, he would turn on the bulk of the Grand Fleet, which would inevitably deploy from its base at Scapa Flow. This too would be monitored by the screen of Zeppelins and U-boats. The U-boats deployed to their positions in mid-May. But the need to repair vital ships and poor weather so delayed the operation that von Scheer had to modify his plan. Now he would first send out his battle cruisers to trail their coats off the Norwegian coast to tempt the British battle cruisers out. The German battle cruisers under Admiral Franz von Hipper duly set sail in the early hours of the 31st of May 1916. 50 miles behind them came the High Seas Fleet main body. 5 Zeppelins were to act as their eyes. But Admiral Sir John Jellicoe, commanding the Grand Fleet, had been told by naval intelligence that the German fleet was about to sail. He therefore left Scapa Flow late on the evening of the 30th of May. Jellicoe also ordered the battle cruisers under Admiral Sir David Beatty to rendezvous with him off the entrance to the Baltic. Beatty had with him the seaplane carrier Engadine, which now carried 2 short 184s for reconnaissance and 2 Sopwith babies, whose task was to ward off the prying eyes of the Zeppelins. Beatty reached the rendezvous first and clashed with von Hipper's leading ships. At this point, he ordered Engadine to launch one of her shorts. This was got airborne 27 minutes after the order was received. The pilot located the remainder of Hipper's force and radioed the details back to his mothership. But Engadin's attempts to relay these to Beatty's flagship met with failure. The Zeppelins too had their frustrations as the two mighty battle fleets closed. Low cloud and mist obscured their vision. Nevertheless, one airship did spot the British ships and radioed 4 reports in the early hours of the 31st. Unfortunately, its navigation was at fault, and the crew placed the British vessels some 30 miles away from their actual position. These were the only contributions that the aviation of each side made to what became by far the largest fleet action of the war. The Battle of Jutland saw the German ships forced to turn for home. Indeed, apart from one abortive sortie later that summer of 1916, the High Seas Fleet remained in port for the rest of the war. But while naval aviation was largely frustrated in its efforts to be the eyes of the fleet, Jutland served to concentrate the minds of the admirals on how it could be made more effective when operating with major warships. The British especially drew important naval aviation lessons from Jutland. The battle confirmed that aircraft operating with the fleet had 3 roles. The primary role of naval aviation was seen as reconnaissance. The second task in those pre-radar days was the control of ships' gunfire to make it more accurate. But there was also the need for aircraft to prevent hostile air reconnaissance from spying on the fleet and thereby frustrating its operations. The original seaplane carriers, like the Engadine, had been modified to enable aircraft, including land planes, to take off from the deck. This meant that they could be got into the air more quickly than in the days when they had to be lowered into the water. But while it was simple enough for the carrier to recover the seaplane after a sortie, these aircraft lacked sufficient performance to be effective in the counter-air role. Only a land plane was capable of this. But how could the problem of recovering it intact at sea be overcome? The diminutive but highly maneuverable Sopwith Pup had been issued to the Royal Flying Corps and the Royal Naval Air Service in the late summer of 1916. It had served on the Western Front, but by the summer of 1917 it had been made obsolete by the arrival of more powerful fighters. However, The RNAS saw its potential as a naval fighter, which could tackle both hostile planes and, more especially, the German Zeppelins. As for a ship from which to operate the pup, the Royal Navy had been building a new carrier, HMS Furious. This was a light battlecruiser with 18-inch gun turrets fore and aft. Early in 1917, the Admiralty decided to remove the forward turret and replace it with a flight deck. Trials were carried out that autumn with Sopwith pups and larger 1.5 strutters fitted with skids. But while taking off was no problem, deck landings proved to be very difficult. Squadron Commander Dunning did achieve the first successful deck landing in his pup on the 2nd of August 1917. But 5 days later, he lost his life when the deck crew could not prevent his aircraft from going over the side, and he was drowned. It was therefore decided to remove the aft turret and construct a landing deck in its place. But landings still proved difficult. Eventually, it was realized that having a central bridge and funnel created too much turbulence in the air for the pilot to be able to control his landing. Therefore, for an aircraft carrier to function properly, there needed to be a flight deck running uninterrupted the length of the ship. The result of this realization was HMS Argus. Argus had been originally purchased by the Admiralty as a half-built liner and was therefore relatively easy to convert. Apart from having a fully flush flight deck, she also had a wheelhouse which could be retracted when flying was taking place. Her below-deck hangar could accommodate 18 aircraft. Argus proved to be very successful, but joined the Grand Fleet only in the very last weeks of the war. Nevertheless, she's important in the history of naval aviation as being the first true aircraft carrier as we know it today. Certainly, deck landings were still a challenge for the pilot, as they are today, but at least he could be confident in controlling his aircraft. Arrestor hooks and barriers helped to bring his aircraft quickly to a halt. Other ways of operating land planes at sea were also tried. One technique was the aircraft lighter, which provided a flat and unimpeded flight deck. These vessels, however, had to be towed and were too slow to operate with the main fleet. More ingenious were trials carried out in the spring of 1918 with the aim of providing individual warships with their own integral fighter protection. The fighter was taken out to the warship and winched aboard. It was then positioned on a ramp. This was made up of wooden boards laid across a gun turret. Using this method, not just Sopwith pups, but camels and 1.5 strutters successfully launched themselves into the air. A major advantage of this method was that the plane could take off into the wind without having to maneuver the ship, for the wind was needed to assist it in obtaining flying speed. As for recovering the aircraft, they were fitted with airbags, which were inflated as they landed on the water. The pilot, however, had to be somewhat athletic to avoid getting wet. But too rough a sea could also result in the aircraft being badly damaged on landing. Even so, a number of British warships were equipped with fighters by the end of the war in 1918. During 1917, the British Grand Fleet also began to re-tackle the problem of seeing over the horizon. This was especially in the context of controlling the fire of the ship's guns. The early balloon vessels, while they had proved successful in directing fire against hostile coasts, were unsuitable for operations with the fleet. Consequently, the British Grand Fleet began to fit balloon winches to its ships. The balloon was inflated on shore and then delivered to the vessel. It was then permanently towed and only hauled down for the observer to climb aboard or dismount. At the end of the war, over 30 British warships were equipped with balloons. By then, a major new role for navies had developed. From 1915 onwards, naval aviation had been presented with a new challenge: anti-submarine warfare. It was the Germans who began to use the submarine as a means of throttling Allied supply lines and maritime trade. In 1914, the rules of war dictated that submarines could only sink merchant vessels after their crews had been given time to take to their lifeboats. However, a British naval blockade instituted at the outbreak of war put a slow stranglehold on Germany, and in 1915 the Germans began to retaliate with a campaign of unrestricted submarine warfare, sinking merchant vessels without warning. But the small number of U-boats initially available meant that the campaign took some time to make its effects felt. By the spring of 1917, with a much enlarged submarine fleet, the situation was very different. Indeed, there was a real danger that Britain might run out of food. Something had to be done. The German U-boats did have a major vulnerability. Their batteries had only sufficient power for them to remain submerged for an hour at a time. Consequently, they spent most of the time on the surface, and this made them relatively easy to spot from the air. The British had begun to deploy small, non-rigid airships called SS, or submarine scouts, during the summer of 1915 to patrol the North Sea. The blimps, as they became known, had a speed of 50 miles per hour and were surprisingly maneuverable. The Admiralty also developed the larger coastal or C-class and North Sea airships. While these flew little faster than the SS airships, they had larger crews and greater endurance. In order to keep the envelope filled and at the correct pressure, these non-rigids used a pipe projecting downwards towards the engine. This enabled air to be channeled by the propeller, a simple but ingenious system. The British also produced larger rigid airships, some based on the design of a shot-down Zeppelin. However, these rigids lacked the maneuverability needed for anti-submarine patrols and were not used to any great extent, although in 1919 one would make the first double crossing of the Atlantic by air. The maritime patrol airships did carry bombs for use against submarines, but they were found to be too unstable a platform for accurate attacks to be made on a small target like a U-boat. They did, however, have radio and signal lamps, and were able to direct surface warships to the scene. These would then attack, provided they arrived in time. In truth, the airships acted mainly as a deterrent, forcing the U-boats to spend more time submerged than they wanted to. While they could remain aloft for as long as 24 hours, patrols over the North Sea and into the Atlantic were a monotonous business for the crews. Much of the problem was that the airship was easy to spot, and its relatively slow speed meant that the U-boats had plenty of time to dive and get out of harm's way. Able to fly at least twice the speed of an airship and more difficult to spot, aircraft had more chance of making direct attacks on submarines. Float planes, however, lacked the endurance to be effective submarine hunters. But the British found the answer in the flying boat. They had begun experimenting with types developed by a famous American pioneer. This was Glenn Curtiss, who had built his H-series America flying boats with a view to flying the Atlantic. A British Royal Naval Air Service officer, John Port, standing on the right, had worked with Glenn Curtiss on flying boats before the war and knew his designs intimately. Port was commanding a North Sea naval air station and arranged for the Americas to be adapted to a new breed of flying boat, which became known as the Felixstowe, after the name of his airbase. The Felixstows were based on Curtiss's H-12 large America design. They were well armed with machine guns and also carried nearly 500 pounds of bombs. Port changed the shape of the hull for one that was stronger and larger. The redesigned hull enabled the flying boat to operate in much rougher seas than the original H-12. Port's redesign also enabled more defensive armament to be mounted. The Felixstowe could remain airborne for nearly 7 hours, over twice as long as the normal seaplane. Operating from Port's base at Felixstowe, these flying boats would soon make their presence felt. In the spring of 1917, the Felixstows began to operate what was called the Spider's Web patrol routine over the North Sea. This was at the very time that America entered the war, and also when merchant ship sinkings were increasing sharply. The Spider's Web was an imaginary octagon, 60 miles in diameter, centered on a lightship. 8 radial arms projected from the center. Cords joined the arms, and the flying boats systematically searched each of the sectors created, covering some 4,000 square miles of sea. The Spider's Web covered the main routes for U-boats leaving and returning to German and Belgian ports. Because of the limited length of time which the U-boats could spend submerged, the flying boats had a good chance of catching them on the surface. Indeed, during the first 3 weeks that the Spider's Web was in operation, no less than 8 U-boats were sighted and 3 of them attacked. The U-boat crews became increasingly concerned. Their concern was heightened in the summer of 1917, when the Allies finally took to sailing their merchant vessels in convoy. Not only were these escorted by surface warships, but when they approached British waters, they had airship cover as well. This now had new relevance, since the Atlantic was increasingly filled by convoys of American troops en route for France. One German answer was to deploy a new type of seaplane to the Belgian coast. This was the Hansa Brandenburg W-12, which was unique in being designed specifically as a fighter. This led to an increasing number of clashes between them and Allied aircraft over the North Sea. One result of these encounters was the development of air-sea rescue. This was a service which would come to save an increasing number of lives at sea in both war and peace. By the beginning of 1918, the US Navy was also playing its part, with its substantial surface fleet being a welcome addition. However, America's minimal military aircraft production base when it entered the war in April 1917 meant that the Navy had to use British and French seaplanes and airships. By the end of the war, the spider's web was increasingly forcing the U-boats to traverse the North Sea by night. Yet out of the 178 U-boats sunk during the war, only one was confirmed as the victim of an aircraft. 25 years later, when the Second Battle of the Atlantic was fought, the situation would be different. During what became the longest campaign of the Second World War, anti-submarine vessels would be equipped with ever more sophisticated detection devices and increasingly effective weapons. But this was only part of the answer to overcoming the U-boat. It was advances in aircraft design, weapons and detection devices which would be even more dramatic and decisive. The result was that almost half the U-boats sunk would be at the hands of aviation. Yet by the end of the Great War, in November 1918, naval air power had made remarkable progress. 4 years earlier, it hardly existed. Now it was recognized as a vital element of sea power. Indeed, the roles which naval aviation fulfills today, 80 years on, were almost all firmly in place. They merely required the necessary technology to make them as decisive as they are today.